Hi students, please make sure you watch this video before Tuesday's class. You have a 3-day weekend, so I hope you spend some of that weekend watching this video and looking over chapter 13. Remember, it's never a bad idea to read through your textbook ahead of time and familiarize yourself. If I were you, I would watch this video, I'd have my textbook open, I would have my notes, I would in one section write down what's on the video, in another section I'll write down some questions that I can ask in class. Remember, my goal is to introduce to you the idea in this video, so when you come to class we can go a little bit deeper, okay? But I want to make sure you watch the video before you come to class. As always, let's start with some reminders. Here are your assignments for the week. This one will be due, we'll get started in class on Tuesday, and then we'll turn it on Wednesday. Remember, these are all due at 3:10, okay? I choose 3:10 because that's the end of the school day. It's not midnight. And then also this coming Wednesday, there's back to school night, okay? I know Wednesday, your bell schedule for the day is a little bit different, but we'll still keep it at 3:10 as a due date. I please beg you to invite your family to back to school night. It's a short 15 minutes meeting. It's the same link as the office hours link, okay? So you can help your family log in, or they can just click on the link that will be provided. Today we want to talk about observational studies and how they differ from an experiment. Okay, these are terms you've probably heard a lot of in your science classes or just in regular media. Things like these are brought up all the time in the news, articles about comparing one thing to another, right? So it's a good idea to know this. You know, the great thing about our AP Stats class is that you hear about stats everywhere, from entertainment to current events to your other academic classes. So an observational study is anything, we're looking on page 293, is where the researchers or the statisticians or you don't assign anything, you're just simply observing and watching. You know, back in the old days you would have a clipboard, probably wearing a white coat and just writing down information. Okay, you're simply observing. So what I like to do is I like to depict observational studies with a pair of glasses. With these glasses, we're just simply looking, okay? You can even use your own glasses. An experiment, on the other hand, there's a lot more that goes into it. And to depict this, I like to draw. No, these are not cacti. Oh, sorry, I made that finger a little bit too long. Okay, yeah, these are hands. Yeah, well, whatever. So with an experiment, there's a lot of manipulation that goes into it. You're manipulating the participants or the experimental units. You're manipulating the factors, okay? So we're going to spend this chapter talking a lot more on experiments, but we still need to know the difference between the two. So let's first start. Sorry about that finger. I didn't mean for it to stick up too much. An observational study. So it starts on the bottom of page 293. An observational study, you just simply observe. Hence, observational study. You're just watching. Okay? You're just note-taking. There's two types here. The first type we have is called a retrospective study. Retrospect, right? When you say in retrospect, you're talking about something in the past. So retrospective study just looks at past data. Okay? The other one on the next page is on page 294, prospective study. at current and or future data. Okay, so that's prospective. Prospective could be you follow the baseball statistics of your favorite player. It could be, I track how well current Marshall students do in college, right? Like if I chose you to be part of a study, and you can know it or you could not know it, I'm observing you from now until you go to college and maybe beyond that. Okay, so it's looking into the future. So remember, this one is future, and this one is simply the past. So observational studies, you're just looking back at information or you're looking ahead. You are a non-participant and you're not involved. You're just gathering data. Experiments with the hands, right, manipulates participants. Okay, an example of this, participants. An example could be where you randomize. Okay, or factors. Okay. So a good experiment, what it does, number one, it manipulates, and then it randomizes, and then it compares. Okay. When you hear about new medications, new drugs that come out to the market, right, you always have to conduct an experiment to see how effective or even harmful these things are. So right now, the country has been talking a lot about developing a vaccine for the coronavirus. Well, in order to test to see if this works, you would need a group that receives the vaccine and a group that doesn't. And a lot of times, they give this as a placebo. And I think you're familiar with that term, but we'll talk about more later. You could have multiple levels. So right now in the experiment that I just explained, you have two levels. You have a group that did not receive the vaccine and a group that did. Or the group that did not receive it could be a placebo. Well, what you could do is you can give one group a placebo, one group half a vaccine, another group a full vaccine, and you can compare those three. So it doesn't always have to be one group compared to another. You could have multiple groups, and these are called factor levels. Okay, there's a lot more vocabulary that goes into an experiment, so I want to talk a little bit more about that before we go into examples. Okay. So in this area, you always have, so back to experiments, has an explanatory variable, aka factors, and a response variable. Okay. So in the example of the coronavirus vaccine, the amount of vaccine that you give to an individual could be your explanatory variable. And the factors, right, we have three factors. We have the placebo, we have half a vaccine and a full vaccine, and your response variable is anything you choose it to be. It could be the number of days it takes for someone to recover from the coronavirus. It could be the number of, like healthy cells in their body. So there's a lot of ways that you can measure that. Okay. A treatment is a combination of factors. Okay. If you wanted to introduce another factor, the combination of those factors would combine to what we call a treatment. Okay. So we'll go through more examples with that, but I'm just going to go over vocabulary right now. Another term that you'll need to know is subjects, participants, or experimental units. Okay, these terms all mean the same thing, sort of. You know, subjects and participants, we usually talk about humans, right? If a human was participating in an experiment. However, what if you were measuring the effectiveness of laundry detergents or washing machines, right? Those would be units. Or you want to see how clean dishes are. You wouldn't call a dish a participant or a subject. You would call it an experimental unit or a unit. Now with animals, you know, if we wanted to check, like back in the day, people would always say, you know, shampoo, they would test it on animals, and PETA and other animal rights groups thought that was inhumane. So a lot of times if you go look at your shower bottle or conditioner, it might say on there, like, no animals were used in the testing of the effectiveness of this shampoo product, or something like that in the fine print. So up to you how you feel. You can call animals experimental units or participants or subjects. Participants kind of implies that people are willingly participating, right? So again, up to you. Okay? So we'll go deeper with some other examples, but what I want to do now is just go over a few scenarios to see if you can understand the difference between an observational study and experiment. Let's say I wanted to compare home runs in Major League Baseball from let's say since 2019, since that was the last full season, to let's say I don't know, we'll say 1980. So when you do this, you would probably look at statistics from the last season, right? You can look at the total number of home runs. You can look at the average number of home runs. You can look at specific players or specific teams, right? And then same thing for here. So when you do this study, okay, you are not manipulating anything, okay? And the people, you're not randomizing anything. So in this case, this would be a observational study, because you're simply looking, right? You're taking your glasses and you're just watching. Observational study, and since this is in the past, this would be a retrospective study. Okay. Some of you might be saying, well, what if we just randomly selected some players? Yes, you're randomly selecting, but there's no manipulation still. You're simply just observing those randomly selected players and the randomly selected stats. Okay. How about if we wanted to check we want to compare the effectiveness of vitamin C on rats? Have you ever wondered that class? Why do we always use rats when we use experiments? Is it because that no one likes rats and we don't care if we poison them and they die? Is it because they fit nicely into like a box? I don't know. Why is that? Because they're close to humans? I don't know. Okay, so think about how you would run this, right? You would probably have a group of rats and you would split them up, probably into equal groups. You would probably have, this is just, we can say, you can have a factor of no vitamin C. You can give a group half vitamin C. You can give a group full vitamin C. So a group receives this, a group receives this, a group receives this, okay? And you're comparing. I'm guessing you're probably going to randomly assign the rats into each of these groups, and you're going to randomly decide who gets which of these factors. Okay? So a treatment, back to this idea of a treatment, right here. If we had, for the factor of vitamin C level, okay, we had 3 levels, right? We had none, half, and full. Okay. What if we want to see how, let's see, exercise affects this, and we want to check to see if maybe exercise level affects the effectiveness of vitamin C. So another factor you can introduce, factor of exercise. Okay, so this time we could have 2 levels, and that could be none, and then we could maybe do 1 hour. So when we talk about our treatments is how many different combinations can you make out of this? Okay, so you can write it out. You could say no vitamin C with no exercise, no vitamin C with 1 hour of exercise, half vitamin C with no exercise, half vitamin C with 1 hour. You guys get it, right? You can just simply multiply 3 times 2. And when you multiply the number of factors, the different combinations you can have, you have now 6 treatments. Okay? Right here. Because there's 6 possible combinations you can make with the 2 factors. You can have as many factors as you want. But for our case, for our purposes, we'll probably just stick to 2, maybe 3. Okay? Class will continue more on Tuesday, so please watch this video. Encourage your classmates to watch this video. If for whatever reason they don't get the announcement, get the memo that a video has been posted, can you just kindly yell at them and tell them to watch the video? Thanks, guys.